Nasılsınız?
Sağ ol, sen nasılsın? Sara hoş geldin.
Hoş
Hocam hoş
geldin.
bulduk. Nasılsınız?
Teşekkür ederim. Sen nasılsın Abdülmünir?
İyi hocam. Çok şükür.
Sağ ol. Sara merhaba.
Hamdolsun.
Merhaba hocam.
Nasılsın, iyi misin?
Çok şükür hocam. İyiyim. Siz nasılsınız?
Teşekkür ederim, sağ ol. Sercan hocam, oturum sizdedir, buyurun.
Tamam, sağ olun hocam. Hello, this is 13th session. So I will be the chair of this session. There will be 6 presentations in that session. The first presentation is analysis of laminar forced convection for protruding heat sources in horizontal channel in the presence of piezo fan. Salim İbrahim Hasan, Serhan Küçüköy, and Mehmet Akif Ezan has written this paper. You can start.
Hocam sanırım burada değiller.
Değil mi?
Buradayım hocam.
Evet
Buradayım.
hani
Burada.
buradalar mı?
Okey.
Burada, evet.
Okay.
Buradayım hocam.
Hocam aslında bir iki dakika
Pardon.
var da biraz erken başlamış oluyoruz ama.
Okay, we can wait 1 more minutes then. Okay. So the 6 presentations are named analysis of laminar forced convection for protruding heat sources in horizontal channel in the presence of piezo fan, internal flow simulations of effusion cooling in micro gas turbine blades. The third presentation is evaluation of properties of industrial inorganic Westfield polymer composites. The fourth presentation is investigation of the wear behavior of AA6082 against different counterparts. The next presentation is investigation of force distribution of shopping carts on human joints. And the last presentations will be finite element vibration analysis of a functionally graded plate. Okay, I think we are in time. Salim, you can start the first presentation.
Okay.
To repeat, that's session 13, and we are starting with the first presentation.
Okay, I will share my screen. Can you see my screen now?
Yes, we can see.
Okay, thank you so much. Hello, everybody. My name is Salim. I am from Iraq. I am a PhD student in Dokuz Eylül University in Mechanical Engineering Department in Thermodynamic branch. My paper here, I am going to present the second part of my thesis. I have also the last part now. I am about to finish my thesis. I am in writing. This the second part. We chose this results we will present the analysis of laminar force convection of proturning sources in horizontal channel in the presence of piezo fan. Piezoelectric fan, I can start to define the parts of the article, abstract and introduction, and I am going to explain the results and some conclusions. Abstract, I can briefly say the abstract of the article. The main purpose of the research here to analyze the flow and force convective cooling by oscillation of single piezo fan in horizontal channel. This is the application of these fans in cooling of compact electronic device. Piezoelectric fan or piezoelectric material in general, it is one of the smart material that are using currently in the compact high performance electronic devices. Here in the introduction, In this figure, you can see the thermal resistance of a piezoelectric fan compared with the another fans that using in general now in electronic devices. If you see the power consumption, also the fan power consumption, the level of fan power consumption of the piezoelectric fan and the thermal resistance in the low level compared with another cooling components. The principal operation of piezoelectric fan or piezoelectric material. Piezoelectricity mean two inverse effects. The materials that can produce electric when we applied force on it, or the inverse effect when we applied electric charge to this material, it can produce motion or displacement. They utilized this inverse effect by applying electric charge to these fans and utilized this motion, the generating motion or cantilever motion in cooling of electronic devices, because it is very thin materials, low power consumption, low noise compared with another fans. If you see here from experiments, from reference, when we apply the electric charge, when we increase the voltage, we got more displacement by these fans. For example, for A and B and C, if you see the displacement for these fans increase when we increase the electric voltage. We are going theoretically to apply to simulate this motion and how we can combine with the fluid mechanics, with the flow and with heat transfer in fluid structure interaction, and how we will get results and show the performance of cooling. Accordingly, the main objective of this study, by console software, we will analyze the cooling effect for and vortex generation by this fan. We will analyze the oscillation motion and how it is effect on airflow, and to compare the performance for protruding. We have two effects here. We will mix the vortex generation by piezoelectric fan and vortex generation by flow in the presence of protruding heat sources. These two effects, how will improve the cooling performance in electronic devices. Here some literatures. In the literatures, they are not using piezoelectric fan and this motion, but they are using active or passive different geometrical. They are put in the stream flow and the study effect of the heat sources. For example, here, if you see in the for active cooling, they are using oscillating bar, and there are another using active cooling but rotating plate, and there are triangular shapes and oscillating cylinder and delta winglet, and so all of them they are analyzed the fluid mechanics, also heat transfer. They are different. They are using different methodology for the analysis. They are get good results. It is applied in electronic cools and other applications. The subject of study to focus on the questions we can ask this question: how we are trying to find the answer to our question whether or not the existence of piezoelectric fan in the channel that contain heated obstacles can achieve uniform heat transfer rate or not. Definition of the problem. The problem is set up by console multiphysics. The problem was 2D problem, laminar flow 2D problems. With the geometry, we have three main geometry: the wall of channels and the heat sources and cantilever motion of piezoelectric fan. This is defined by dimensions according to the channel heights. This channel heights selected from the literatures according to the analysis of channel. For example, if we have a compact electronic device like PC or laptop or another electronic package, and the specification of the material, it is very important in the analysis because all equations depend on the calculation and analysis of motion of the piezoelectric fan depending on the material of the piezoelectric fan. Here, the summary of calculation of motion, or how we will get motion. The motion is defined by functions adding as variables. We have, for example, the length of the piezoelectric fan and the specification of material of piezoelectric fan. It is combined in the equation of motion. This equation of motion analysis we can find in many textbooks of the solid mechanics. For cantilever motion. For cantilever motion, there are a complex equation. It is simplified in the literature. We use, for example, for X motion, X direction, the direction will be oscillation on the Y direction. For calculating the displacement, when increase the frequency, the displacement increase. And we are now take one cases. We have many cases in the thesis. Take one cases at frequency 20 hertz. For example, for the length of 60 millimeter of the piezoelectric fan, we get displacement about 5 millimeter. 5 millimeter this displacement up and down, and how it will continue. It will continuous by another equations. This equation it is defined in the multiphysics by study, by time-dependent study, by defining the time steps and with constant frequency, and then all of this defining is combined in automatic remeshing. We have moving boundary condition here. When we increase the frequency, if you see in the right figure, there are four frequency. If you see the amplitude up and down of the motion of the piezoelectric fan, when we increase the frequency, it is increased. Also the velocity of the tip of fan, we can calculate it from the theoretical equations, and it will be increased. For example, for at frequency 35 hertz, it will be maximum, and for 15, it will be minimum. Then the mathematical model, after we defined all the variables of the motions, the mathematical model boundary condition defining the inlet and outlet condition for the channel, and then top and bottom walls, then defining Reynolds number in the range of the laminar flow, and the governing equation in fluid flow and heat transfer, depending on the solving of Navier-Stokes equation, continuity and momentum and energy equations. It is defined in flow field physics, as physics we added in the model. Then combined it with the heat transfer and multiphysics. Multiphysics flow, we have two parts: FSI, fluid structure interaction, and also isothermal flow. By combining this physics, after defining the meshing, we also do test for mesh, different meshing. We are using different size of mesh to get the results. Then defining it in the automatic remeshing, defining it as physics in the solid mechanics. Then the combining the physics will be fluid flow with the solid mechanics by FSI and fluid flow with heat transfer by isothermal flow. Then all of them defining by automatic remeshing, because we have a moving boundary here to get the results. And here we have to calculate for heat transfer section average Nusselt number and average heat transfer coefficient. This the first results for test of meshing, checking the meshing for during the 5 seconds of the piezo fan flow. We have 0.1 meter per second inlet velocity as for convection in the range of fluid flow. And then we get here results. There are very small difference between the results. Then we choose the number of mesh 9,600.
Salim, by the way, you have 1 minute left. Maybe you can conclude
Okay.
quickly. Okay, because the length of presentations is just 15 minutes.
Okay, I will go fast. Here I am coming to the results quickly. The results, two parts: flow consideration. If we see here the comparison between in the presence or not with or without piezoelectric fan. If you see here the velocity, the maximum velocity in the at the tip of piezo fan, it is 2.5 meter per second. Compared without piezo fan, it's just 0.1. Then the thermal consideration. If you see here uniform for without piezo fan and vortex generation, you see maximum the amount of the temperature. The temperature contours show maximum for the without piezo fan and minimum for in the presence of piezo fan.
Okay, so you can conclude. We are out of time.
Okay,
and just conclude with a few seconds.
Okay, just this is the last slide. Here also maximum and minimum. You see this the blue lines for in the presence of piezo fan, and without piezo fan it is red line. And we can conclude. We conclude some results in the presence of piezoelectric increases the performance of cooling. And it is we have many parameters. We can study here the position of piezo fan and the height of the heat obstacles, heat surface, and the effect of the mean stream flow velocity. We have many results here, but we have limited time to show it. And this is the reference. And thank you for
thank you for your nice presentation. You can ask your questions in private to Salim. So it was an interesting presentation. Thank you. Now the second presentation is internal flow simulations of effusion cooling in microgas turbine blades. It's prepared by Süleyman Fatih Kırmızıgöl and Sercan Acerer. Okay, you can start. And you have a time of 15 minutes, Fatih.
Thank you, sir. I'll present now. Hi to all. My name is Süleyman Fatih Kırmızıgöl and my advisor is Sercan Acerer. We will present here internal flow simulations of effusion cooling in microgas turbine blades. Gas turbine engines work in a Brayton cycle, shows in temperature entropy graph. The graph tells us is happening what is in the gas turbine engines. Briefly, 0 to 2 is air inlet region. 2 to 3 is compression region. That is the air is compression here. Pressure and temperature is increasing. 3 and 4 is combustion chamber region. The temperature reaches maximum level in 0.4. 4 to 5 is turbine region. That is more critical part, because the highest temperature reaches at 0.4 and it is cooling. The temperature is cooling goes to 5. The temperature blade is cooling. The turbine cooling technology is needed to create more output power by increasing turbine inlet temperature. To preserve the blade from thermal stresses, we should cool it down. Our aim is our aim is to develop one day reduced order model. We have cooling techniques, and we will present here such of most of them. One is a convection cooling technique. This is coolant goes from inside of the blade, and mainstream goes from outside of the blade, and coolant and mainstream doesn't come across. This is a simple cooling technique. The second one is impinging cooling. Cooling by using high speed and impinging on the surface of the inner surface of the blade. Same as here, mainstream goes from the outside of the blade and don't come across each other. Effective cooling technique than the convection cooling technique, because here is coolant is impinging on the inner side of the surface. The third one is film cooling technique. This is most common technique, most known technique. Coolant is going inside of the blade and run out of holes, and it is affect the mainstream directly. In here we have cooling holes. The cooling hose has a big diameter, and the distance is each between the holes is big, and we have less dense holes. The fourth one is transpiration cooling. The coolant is here is also going from inside of the channel and goes out of the porous region. Here is the material is porous and weak material structure. This is a perfect cooling effect. This provides perfect cooling effectiveness, but it is not a common technique. It is not a common technique because of weak material. The last one I want to present efficient cooling technique. Efficient cooling technique is between transpiration and film cooling technique. It is the cooling technique is provides more cooling technique than the film cooling because it has more holes than the film cooling technique, and it has small diameter and small distance between the holes. As I mentioned before, our aim is to create 1D model, and we should firstly validate our numerical model, that is ANSYS Fluent, for the future works. We selected C3X turbine blade because it is most known blade, and available data. There's an available data for heat transfer coefficient, static pressure, and adiabatic wall temperature on the suction side and the pressure side. It is published paper, and there is an experimental work in here. We created a geometry by using ANSYS Fluent as a 2D geometry. This is our validation case. We have also external hut, has inlet and outlet, which length is 2 times of vane spacing. The mesh structure is you can see the figure A. This is a general mesh structure. We have 250,000 elements here. A detail figure is B, and detail of cooling channel mesh structure is shown in figure C, and detail of blade mesh structure is shown in figure D. We have less than, y plus is equals to 0.36 less than 1, and grow rate is 1.2. We used inflation layer on the cooling side because we have convection cooling, convection boundary condition in the cooling channels. As you can see in the turbine blades, there are 10 holes, there are 10 free stream temperatures, and there are different 10 heat transfer coefficients. The other boundary conditions is for the external flow, inlet and outlet region. We define it for inlet, total pressure, total temperature, turbulent intensity, and for the outlet outlet region, we define it static pressure. Also, the other boundary conditions is periodic boundary condition. To define it, the other boundary condition is periodic boundary condition. The validation case, the experimental case says that we have Mach number and Reynolds number in leading edge and trailing edge. And our numerical solution says that it is closer to these experimental values. So we can capture the flow physics what we in our case. The other validation case, the most important thing here, we tested 5 different turbulent closures: K omega RSM, K epsilon realizable, K epsilon maintain length transition SSD. The figure shows static pressure on the surface of the blade, dimensional static pressure. The black one shows the experimental data, and the other lines shows the dashed lines shows the turbulent closures, and all of them captured very well for the static pressure. The critical region for the critical validation for heat transfer calculation and wall temperature. In here, K epsilon maintain length, the red one, well agreed with experimental data, which is black one for the heat transfer coefficient, and it is well agreed with wall temperature, well agreed with maintain length results in the wall temperature on the surface of the turbine blade. In this case, for the future work, our model is K epsilon maintain length, and we selected our mesh structure. For the future work, we divided turbine blade into 2 regions. One is inner cooling side, the other is outer mainstream side. Our aim is create a 1D model that can predict the numerical model results by using MATLAB that will predict temperature, velocities, pressures, Mach numbers, like that inside of a main channel and outside outlet of the effusion holes. We the part of numerical simulation, we can say that we created we want to create 3 different geometries by changing P over D parameters. It will equals to 5, 10, 20. We created these geometries, and we want to create these geometries and simulate by using ANSYS Fluent. And then we want to create 1D reduced order model. The logic is like that. We act it like a 3D model, and we think it like that. We have 4 control volume. As a control volume 1, it is the inner coolant channel, the cold side. Control volume 2, inner channel, the hot side. control volume 3, fusion holes, which is shown in red. Control volume 4, which is shown in gray, that is metal side. We divided all the
Fatih, by the way, we have 2 minutes, including questions.
Okay. We divided all the metal section main channels, and we will take pressures, velocity, temperatures by using isotropic relations, pressure drop, and Nusselt relations by providing energy balance, and we will compare numerical simulation and our 1D reduced Odin model. Thank you, and any questions for this presentation?
Okay, do you have any questions? Okay, I think there are no questions, but we have 1 more minute, so we can wait 1 more minute. If you have any questions in that interval, you can ask. Okay, so we can start the third presentation. Thank you, Fatih, for your nice presentation. The third presentation is evaluation of properties of industrial inorganic waste filled polymer composites by Selim Ildır, Mustafa Öncül, Metehan Atagür, and Kutlay Sever.
Thank you, Sercan Hocam. Hello, everyone. My name is Mustafa Öncül. Our topic is evaluation of properties of industrial inorganic waste filled polymer composites. The presentation titles are Introduction, Objectives, Materials and Methods, Results and Discussion, and Conclusion. As you know, there's an increasing tendency to reduce environmental pollution and increase recyclability in all world. And in this study, in order to produce composite material, polypropylene as a matrix and synthetic marble as a filler was used at different ratios. I will show later in table. Tensile, flexural, and viscoelastic properties of polymer composites were determined by tensile test, 3-point bending test, and dynamic mechanical analysis, respectively. And the results show that synthetic marble generally increases the mechanical properties of polymer composites when it added to the polypropylene thermoplastic matrix. Just a quick reminder, composites consist of 2 or more materials that combine with each other. To complete a combination, there must be 2 phases, matrix and reinforcement. As you know, matrix is a ductile phase. It protects dispersed phase from mechanical damage and chemical attacks. The reinforcement phase is added to increase strength and stiffness, carry the load along with its direction. Polypropylene is a thermoplastic polymer used in a wide variety of applications in industry and commodity. Synthetic marble selected as inorganic waste material in this research. One of the reasons is to minimize the damage done by this material to the environment, and the reason why we use as reinforcement in this research. The objectives, the main focus of this work is to bring new knowledge to the literature by using inorganic waste. And ceramic-based waste are hard to recycle, and one of the main affairs in environmental pollution. And synthetic marble was chosen not only its complexity of recycling, but also its contribution to the composite material. Materials and methods. We use polypropylene, PP, from LG brand as a matrix material, and the filler material is synthetic marble, SM, from Belenko company. We supplied in Manisa. And just a quick explanation about composite manufacturing. The first step in the production phase is drying of the substance in order to prior to us to get rid of the humidity. And second step is grinding. The operation was start with ceramic pastel grinding with hand force and continue with mechanical grinding machine. The fourth step is sieving. We use it to eliminate big sizes under 10 nanometers, micrometers. And the fifth phase is the using thermokinetic mixer to manufacture this composite material. And lastly, we use hydraulic press to get the samples for ready to test, tensile test, and dynamic mechanical analysis. The table, which I mentioned previously, table 1, you can see here the sample codes of materials and produced composites. We had from 5 to 20, 5, 10, 15, and 20% of synthetic marbles. And you see the universal testing machines with samples. We use it for tensile test and bending, means flexural test, and dynamic mechanical analysis, and the manufactured samples. After manufacture parts and complete test, we got firstly the tensile test results. You see on the left tensile strength in terms of megapascal and the composite materials. And you see on the right side the Young's modulus and the materials. And we see here the decrease in the tensile strength of composite material. The reason should be weak interaction between filler and matrix becomes more pronounced and leads to deterioration in tensile strength and higher filler loadings. In terms of Young modulus, you see the increase in 10% and 20% SM. This increase in the modulus of PP can be caused by the substitution of PP by the largely more rigid filler, and the filler restricting the mobility and deformability of the matrix by introduction of mechanical restraint. And from the 3-point bending test results, flexural test, we see some increases in 10% in terms of flexural strength, and again in 10% SM we see the increase in Young modulus. And the flexural strength is very important for automobile parts, especially bumper molding, front fascia, and body side molding. So this slight increase gives us a good motivation. And in terms of Young modulus, the increase in tensile and flexural modulus of PP can be explained by the substitution of PP by the largely more rich mineral filler, and mineral fill restricting the mobility of the matrix. And dynamic mechanic analysis, I hope you can see the colors from blue one to purple one. And after dynamic mechanic analysis, we got the storage models by temperature results and loss models by temperature results. The interpretation is these results. The storage modus of PP is increased with the loading of synthetic marble, SM. 10% SMPP composite has better storage modus at low temperatures. This is due to the fact that the fillers at high concentrations reduce the mobility and the formability of the polymer matrix. Also, the stiffness of PP increased owing to the mechanical restrictions on molecular motions in the matrix imposed by the SM particles. In terms of loss modus, a decreasing trend is seen in the storage modus for PP and its composites. This may be ascribed to that as the temperature increases, the mobility of side chains of polymer becomes easier. And the variation of the addition of SM into PP causes a significant increase in the crystallinity of PP. It can be attributed to the nucleation effect of SM by increasing the rate of nucleation and mobility of the polypropylene chains. After the results, it can be concluded that the main the main objectives of this research are to produce polymer matrix composite material by using industrial inorganic waste material and to eliminate one of the most harmful inorganic waste from nature. Tensile, flexure, and dynamic mechanical analysis tests were used to determine the mechanical behavior of manufactured composite materials. And in summary, the effect of synthetic marble powder loading into polypropylene was investigated in terms of mechanical behaviors. And in general, we can say that the results shows us this synthetic or artificial marble generally increases the mechanical properties when it's added to the polypropylene thermoplastic matrix. Thank you for listening. If you have any question.
Thank you very much for your presentation. Okay, do you have any questions? Okay, Mustafa Hocam, we have 5 more minutes or 4 more minutes until the next presentation. Maybe you can make additional, you may give some additional information if you have.
May I speak Turkish?
Yes, sure.
Okay. Ya daha rahat hissedeceğim için özellikle bu pandemi dönemiyle alakalı sunumda bahsetmedim. Bizim direkt konuyla alakalı olmadığı için ama özellikle hepinizin bildiği gibi bu plastik ham madde kısımlarında termoset olsun, termoplastik olsun ülkemiz çoğunlukla dışarıya bağımlı. %90 üzerinde belki. Ve özellikle son 6 ayda bu fiyatlar 2'ye katlandı. Ki özellikle bu commodity dediğimiz işte yani PET'ten tutun veya günlük hayatta kullandığımız hani mühendislere girmeden daha mühendislik malzemelerine geçmesek bile o üçgenin en altında olan plastik kısımlar 2'ye katlandı fiyatları. Bu da yani üretici gözle veya işte bizim araştırma kısımlarına baktığımızda işte bu ham madde kullanımı ne kadar azaltırsak işte dolar çıktığımız ülkemizin bu ihracat açığını bir nebze olsun azaltılması amaçlanıyor. Bu perspektiften yaklaşıyoruz. Bu bahsettiğim zaten commodity kısmıydı. Engineering kısmına hiç girmiyorum. Orada zaten hem daha yüksek meblağlar hem daha yüksek teknoloji gerektiren çalışmalar var. Yüksek. %5 bile bir katkı maddesiyle siz işte plastik malzeme diyeyim artık genel anlamda bunun kullanımını azalttığınızda ve bunu toplama vurduğunuzda, özür dilerim, burada çok büyük fiyatlar, meblağlar cebimizde kalmış olacak. Sunumda bahsetmediğim bir perspektif de buydu. Süremizde müsaade ettiği için ekstradan dile getirmiş olduk.
Okay, do you have any questions? Okay, we still have around 2 minutes to start on the schedule. We can wait until the next presentation.
Merhabalar. Sunumu açmaya çalışıyorum, anlatacağım.
Bir 2 dakikamız var. 2 dakika bekleyebiliriz. Takvime
Tamam.
göre 45 geçe başlayabilir. Hani o saatte girecek olan katılımcılar varsa onlar açısından
Tamamdır.
bir dakika kaldı hatta. 1 dakika bekleyebiliriz.
Tamam.
Okay, so time has come. Now the fourth presentation will begin. Its topic is investigation of weird behavior of AA6082 against different counterparts. And Safiye, İpek Ayvaz and Mehmet Ayvaz have prepared it. Okay, you can start.
Teşekkürler. Tekrardan herkese merhabalar. Ben Türkçe sunacağım sunumu. Sunumumda 6082 alüminyum alışımlarını farklı karşı elemanlar karşısındaki aşınma davranışlarını araştırdık. Birbirlerine karşı izafi hareket eden iki malzeme arasında sürtünme oluşacaktır. Sürtünme sonucunda malzeme kaybı, yani aşınma meydana gelir. Aşınma ve sürtünme olaylarının gerçekleştiği sistemlere tribolojik sistem adı verilmekte. Tribolojik sistem elemanları şekil 1'de görülüyor. Burada ana malzeme, burada basit bir şekil, ana malzeme, karşı eleman, ara malzeme, yani kopan parçalar da dahil buna. Yük, uygulanan yükümüz, malzememizin hareket yönü ve çevre şartları yine bunda etkili. Aşınmada, tribolojik sistemlerde etkili. Tribolojik sistemlerde karşı eleman, yani aşındıranla ana malzeme, yani aşınan malzemenin pek çok mekanik, fiziksel ve kimyasal özellikleri aşınma sürecini etkilemektedir. Alüminyum ve alışımları yüksek spesifik mukavemet, kolay işlenebilirlik, yüksek korozyon direnci gibi üstün özellikler sayesinde otomobil, savunma, gemi inşa, havacılık gibi pek çok sektörde kullanılıyor. Ancak alüminyum alışımlarının düşük aşınma dayanımlarından dolayı kullanımlarını sınırlandıran bir etki oluşturuyor. Yani aşınma dayanımları düşüktür. Fakat alüminyum alışımlarının bu özelliği, bundan dolayı makine elemanları, tribolojik sistem dahilinde çalıştığı alışımların kullanıldığı makine parçalarını örnek olarak koydum buraya. 6000 serisi alüminyum magnezyum silisyum alışımları yaşlandırılabilirlik, kaynaklanabilirlik, kolay şekillendirilebilirlik ve işlenebilirlik gibi özellikleriyle genel kullanıma uygun alüminyum alışımları. Yani bizim de kullandığımız alışım alüminyum alışımı bu. 6000 serisi alışımlar için yaygın kullanımı olan alışımlardan bir tanesi de 6082 alüminyum alışımları. Ancak tribolojik sistemin önemli bir parçası olan karşı elemanında 6082'nin tribolojik özellikleri üzerindeki etkilerini ortaya koyan çok fazla veri bulunmamakta. Yani karşı eleman çok fazla araştırılmamış. Biz bu çalışmada 6082 alüminyum alışımını wolfram karbür 6 kobalt, alümina, 100 krom 6 bileler karşısında tribolojik aşımı özelliklerini inceledik. Çalışmada kullandığımız 6082 alüminyum alışımına ait kimyasal kompozisyonu ve mekanik özelliklerini görüyoruz. Kimyasal kompozisyonda mangan, magnezyum ve silisyum ağırlıklı bir malzeme alışımı olduğunu buradan söyleyebilirim. İlk olarak hassas kesme cihazının numunelerimizi hazırladık. 30 mm çapında, 10 mm yüksekliğinde numuneleri kestik. Kesme işlemi sonrasında ultrasonik banyoda temizledik malzemelerimizi. Daha sonra numuneler yanda görülen parlatma cihazında 100 ve 1200 mikrometre arasındaki zımparalarla zımparalandı ve 3 ve 1 mikrometre elmas parlatıcılarla da yüzeyleri parlattık. Aşınma testlerini CSM trigonometrik test cihazında gerçekleştirdik. Testler ASTM G9917 standartlarına uygun olarak pin on disk yöntemiyle gerçekleştirildi. Aşınma testlerinde karşı eleman olarak 6 mm çapında 100 krom 6, alüminyum oksit, wolfram karbür 6 kobalt bilyeler kullandık. Mesafe olarak 500 metre kayma mesafesi, 0.15 metre bölü saniye kayma hızı ve 5 Newton yükün kullanıldığı testler oda sıcaklığında ve yaklaşık %55-%60 ılı nem ortamında gerçekleştirildi. Aşınma testleri sonrasında aşınmış yüzey incelemelerini Klemex görüntü analiz ve Nikon SMZ745T markalı stereo mikroskop kullanarak incelemeleri yaptık. Sonuçlara gelecek olursak, şekil 5'te de gördüğümüz gibi 100 krom 6, alüminyum oksit ve wolfram karbür 6 kobalt karşı elemanlar ve 6082 sürtünme çiplerine ait kayma mesafesine bağlı sürtünme katsayısındaki değişimi görüyoruz. Tüm numunelerde sürtünme katsayısı yaklaşık 150 metre kayma mesafesinden sonra denge durumuna ulaştığını gördük. Ortalama sürtünme katsayıları 100 krom 6 6082 çiftinde 0.53, alüminyum oksit 6082 çiftinde 0.54, wolfram karbür 6 kobalt alüminyum 6082 çiftinde de 0.50 olarak tespit ettik. Wolfram karbür 6 kobalt karşı elemanlar karşısında 6082 alüminyum alaşımının özgül aşımı oranlarını görüyoruz. Tespit edilen özgül aşınma değerleri literatüre uyumlu bir şekilde sonuçlandı. Ancak beklenenin aksine en düşük özgül aşınma oranı wolfram karbür 6 kobalt 6082 çiftinde görülürken en yüksek değerde 100 krom 6 6082 çiftinde görüldü. Yapılan incelemelerde 100 krom 6 karşı eleman aşınmasının wolfram karbür 6 kobalt birliği oranla daha fazla olduğunu gördük. Bunun sonucunda 100 krom 6 6082 malzeme çipleri arasındaki temas alanının diğer çiplere oranla daha fazla olduğunu tespit ettik. Artan temas alanıyla alanında 500 metre kayma mesafesinde 100 krom 6 6082 çiftinde 6082 özgün aşım oranını arttırmaktadır. Burada 100 krom 6 6082 çiftindeki 6082 alüminyum alışımının aşınmış yüzey görüntülerini görmekteyiz. Burada baskın aşınma tipi olarak agresif aşınma tipi oluştuğunu gördük. Aşınma izi genişliği de ortalama olarak 1500 sonrasında. Alüminyum oksit 6082 çiftindeki 6082 alüminyum alaşımında görülen agresif ve oksidasyon aşınmasını burada yine görüyoruz. Burada oksidasyon aşınması ekstradan bulduk. Tribojik süreç burada devam ederken oksidasyon aşınmadan bahsediyorum. Aşınmış yüzeylerin ve aşınma kalıntılarının oksitlenmesi, bunların yüzeyde tribofilm oluşturması ve bu oksitlenmiş tribofilm yüzeyin tekrar bozulması şeklinde, yani döngü halinde gerçekleştiğini gördük. Yani bir tabaka oluşturuyor, sonrasında bir sonraki dönüşte de o tabakayı kaldırdığını görüyoruz. Yüzeyde oluşan oksit tribofilm ana malzemeye göre oldukça sana düşüren bir etki olarak karşımıza çıktı. Abrasif ve oksidasyon aşınmanın yanı sıra aynı zamanda delaminasyon, çatlaklı kırıklar da oluştuğunu gördük. Alüminyum oksit 682 çiftinde. Bu numunelerde ortalama aşınma izi genişliğini de 1467,1 mikrometre olarak ölçtük. Burada da wolfram karbür 6 kobalt 682 çiftinde 682 alüminyum alaşımında görülen abrasif aşınma ve plastik akmayı görüyoruz kenarlarda. Burada abrasif aşınma, delaminasyonda görüldü, aynı zamanda çatlak ve kırıklar. Oksidatif aşınma da yine aynı şekilde burada da görüldü. Bunun ayrıca aşınma izi, yan yüzeylerinin dediğim gibi plastik akmaya zorlandığını görüyoruz. Burada da ortalama aşınma izi genişliğini 1439,7 mikrometre olarak ölçtük. Sonuç olarak bu çalışmada 6082 alüminyum alaşımının tribojik özelliklerine 100 krom 6, alüminyum oksit, wolfram karbür 6 kobalt karşı elemanların etkisini inceledik. Tespit edilen sonuçlarımız özetle ortalama sürtünme katsayılarımız 100 krom 6 6082 çiftinde 0,53, alüminyum oksit 6082 çiftinde 0,54, wolfram karbür 6 kobalt 6082 çiftinde 0,50 olarak tespit edildi. En düşük özgür aşınma oranı wolfram karbür 6 kobalt 6 metreküp bölü Newtonmetre. En yüksek değer 100 krom 6 6082 çiftinde ölçüldü. Bu da 9,71 çarpı 10⁻⁴ milimetreküp bölü Newtonmetre olarak. Alüminyum oksit 6082 çiftinde 6082 alüminyum alaşımlarının özgür aşınma oranı 8,23 çarpı 10⁻⁴ milimetreküp bölü Newtonmetre olarak belirlendi. 100 krom 6 6082 çiftinde görülen baskın aşınma tipi abrasif aşınma olarak belirlendi. Wolfram karbür 6 kobalt 6082 ve alüminyum oksit 6082 çiftinde abrasif aşınmanın yanında oksidasyon aşınması ve oksit tribofilm gözlendi. Bu okside tribofilm sayesinde bu numune çiftlerinde 6082 numunenin alüminyum alaşımı numunelerinin özgür aşınma oranı 100 krom 6 6082 çiftine göre düşmüş olduğunu belirledik. Teşekkür ederim dinlediğiniz için.
Safiye Hocam teşekkür ederim sunumunuz için.
Ben teşekkür ederim.
Sorularınız var mı? Henüz 4 dakikamız var bir sonraki sunuma. Evet, sorularınız yoksa Safiye Hocam ek bir bilgi vermek isterseniz, hani 4 dakika vaktimiz var bir sonraki sunuma kadar.
Aslında şundan bahsedebilirim belki. Normalde şuradan açayım.
Hocam ben
Normalde,
başını kaçırdım ama mümkünse bir şey sormak isterim ben.
Tabii buyurun hocam.
Bu malzemeyi, yani AA6082'yi seçmenizin şeyi nedir? Yani bu malzeme, neden bunu seçtiniz? Belki başta söylediniz ama ben kaçırdım.
Çok fazla kullanılan bir malzeme hocam otomotiv sektöründe. O yüzden ve karşı eleman olarak da aşınma davranışı çok fazla incelenmediğini gördük yaptığımız literatür çalışmalarında. O yüzden bu malzemeyi tercih ettik.
Bunun muadili diğer malzemelerin fiyatları, yani ekonomik değerleri nasıl buna göre? Bu bir avantaj sağlayan malzeme mi?
Aslında daha çok hani hafif bir malzeme. O bakımdan daha çok kullanışlı ve tabii ekonomik açıdan da uygun bütün diğer malzemelere göre.
Evet. Teşekkür ederim.
Ben teşekkür ederim hocam.
Evet, sorularınız var mı? Başka henüz 2 dakika vaktimiz var.
Safiye Hocam, Mehmet Hocam yok mu?
Evet hocam, aslında evdeyim hocam var ama diğer odada çağırabilirim.
Yok yani o niye izlemiyor diye şey yaptım da.
Hocam çocuklar var da o çocuklara bakıyor.
Tamam,
Ben
çocuklarla ilgili. Tamam. Selamlar kendisine de.
varsın hocam. Varsın söylerim, sağ olun.
Sercan Hocam.
Buyurun hocam.
Ha siz buyurun hocam, ben şey yaptım, böldüm ama teşekkür ederim.
Yok hocam 1 dakika vaktimiz var. Hani süre
Tamam.
vaktinde başlasın diye beklemeyi düşündüm. Safiye hocam aslında 1 dakikamız da var. Belki kendinizden bahsetmek isterseniz bir sonraki sunuma kadar. 1 dakika.
Ben Celal Üniversitesi'nde öğretim görevlisi olarak çalışıyorum. Öğretim görevlisi doktor. Turgut Meslek Yüksekokulu'ndayım. Makine ve Metal Teknolojileri bölümündeyim. Geçen yıl doktoramı bitirdim ben de. Daha çok kaplama üzerine çalışıyorum. Bor kaplama üzerinde daha çok yoğunlaştım. O şekilde sormak istediğim, hani o anlamda sormak istediğim bir şey varsa.
Bunun üzerine
Teşekkür
bu
ederiz.
malzemeyi bor kapladınız mı? Denediniz mi onu?
Yok hocam, bunu daha denemedik ama deneyebiliriz. Daha çok bir titanyum. Aslında ben implant üzerine biraz daha yoğunlaşıyorum. 316L gibi hani daha bir biyo malzeme olarak denemeye çalışıyoruz borlamayı.
Evet. Evet, süremiz de geldi. Bir sonraki sunuma başlayabiliriz.
Teşekkür ederim ben.
Teşekkür ederim
Merhaba.
sunumunuz için. Okay, so we are in the 5th presentation. It's investigation of force distribution of shopping carts on human joints. And by Adil Kılınç, Tarık Akgül, Uğur Kemiklioğlu, and Ahmet Zafer Şener. Okay, you can start.
Okay.
You have 15 minutes, including all the questions.
Hello everyone. Today we will talk about our study where we examine the effect of the shopping cart which we use frequently in daily life on our joints. First of all, in this presentation we will talk about the history of the shopping cart, its production standards and the reasons for the forces affecting the user. And next we will talk about the theory of our work, our designs and analysis, and the results we have found. And we plan to explain these step by step. It was noticed that customers had difficulties in transporting the products they bought during the periods when market change become widespread. And after this was noticed, various solutions were tried to be found. And although there were many shopping carts before, the first significant development was made by Sylvian Goldman in 1936. The shopping cart designs previously made posed a parking problem, and Sylvian Goldman designed the collapsible basket carrier for this and solved this problem. And at first, customers thought shopping carts were unnecessary, but this perception was removed by Goldman's simple fake shopper tactic. And most modern shopping carts are metal or plastic. It's designed to be placed inside each other to take up less space. And there are two types of shopping carts that are widely used today. It's a shopping cart with 4 caster vans, one of which is in accordance with European Union standards, and the other with 2 caster vans with 2 fixed vans in accordance with USD standards. And the reason for this difference can be said as markets in America have wide shelf spaces,
And in our project, we will examine the stresses that shopping carts cause on human joints under various conditions and taking this difference into account. And ACTM 2372 standards are taken into consideration in shopping carts designed to be produced. And ACTM stands for American Society for Testing and Materials. And these standards include consumer safety, performance requirements, test methods, and labeling requirements. And there are different reasons for the stresses in the joints. First of all, frictions are important factors, and smooth surfaces are often used in grocery stores to reduce friction between the floor and valves. And in addition, grease is used to prevent friction in the inner links of the valves. And other factors are the weight of the shopping cart, ramped floors, and the weight of the items loaded on the shopping cart. To explain the stage of our work, first of all, we designed a shopping cart that is very realistic. And later we made various simplifications to the design for analysis. Then we did the dynamic analysis of the shopping cart. And we took note of the data we obtained from these analyses. And later we designed a human model. We made a static analysis using the data we obtained from the shopping cart. And we used the SolidWorks CAD program during the design phase, and we used the ANSYS program during the analyze phase. We used the rigid body dynamic analysis system for the time-dependent analysis of the shopping cart, and the static structural analysis system for the human model. And in the first stage of our design, the actual dimensions of the market car used in daily life were taken as basis. Later, simplifications were made on these design, and cage elements were removed. Rectangular structural elements were used instead of cylindrical elements, and the distance between the valves was increased and the chassis was made into one piece. And we found that the valves of the shopping cart were also complex, and we removed some parts that were not required for analysis, and thus we reduced the analysis time by making less joint definitions. The dynamic analysis of the shopping cart consists of four stages. In the first stage, we will examine the condition of the shopping cart with forecaster valves running straight. In the second stage, we will examine the situation of the moving the shopping cart with its front two valves, caster valves, and the rear two valves, fixed valves. In the third and fourth stage, we will examine the 19-degree rotation of these shopping carts in the counterclockwise direction. And we transferred the shopping cart model to ANSYS. Then we defined the material considering the density. The shopping cart was defined as approximately 22 kilogram, and we defined the 10 kilogram point mass inside it. And later we defined the joint and contact connections of these shopping cart, which consist of 18 parts. First of all, we defined the connection between the shaft and the chassis housing as a fixed connection. The bracket connection with the lower end of the upper shaft was defined as a revolve joint. This connection will add free-rolling movement feature to our cart. In cases where we consider movement restriction for rear valves, this connection will be set as fixed joint. The central or main shaft in the tire and bracket connection was defined as a fixed joint, and a friction coefficient of 0.1 was defined between the valve and the ground. Here, we define the boundary conditions. Since the car will make straight and rotational movements, we define joint displacement and joint rotation according to the situation. Since the application position of the movement will be on the handle, we have defined these joints on the handlebar. We also defined the acceleration of gravity in -y direction to account for its weight. And now, Adil will continue the presentation.
Well, I'm going to start with the static structural analysis system. And we designed actually the human model that we want to examine here under certain conditions and define various elements for some joints that we will measure. And as mentioned before, our human model, which we modeled for our cart, consists of 12 separate parts and weighs approximately 80 kilograms. And it's 1.87 meters long. And for this model, we have prepared, we created a new material definition with the properties we find closest to the human model as a result of our research, since there is no human material required in the material library of ANSYS program. And here are some limbs and the connection relations between them. This is very important in determining how our analysis will take place and how static analysis will result. And here we have defined the ankle neck joint as a bonded contact on the right, as you can see. And this gives us a fixed connection, as we won't be analyzing at these joints, and all other contact surfaces were set as no separation and joints were set as fixed joint, because we don't want any movement here, but we want to see a stress distribution over them. And here are the last three things I want to talk about that it will have an impact on the model. Of course, we are aware that the forces can act on the hands on the model at different angles, but we had to choose a specific application direction as its proximity to realism, and as you can imagine, it would further strain our analysis in terms of technical conditions. And therefore, since the horizontal component of the force that will activate the cart is important to us, considering that the vertical force will be damped by friction. So we neglected this and we decided to apply the force horizontally on human hands. And however, we obtained the most logical simulations that we thought to be close to the real. We could find as a result of our analysis with dozens of variations for the cart, and we recorded the movements that we can obtain from here. And you are viewing the views best suited to our technical conditions for 4 different analyses. And we recorded the solution intervals that the program can solve for 1 second solutions, and we sat in the analysis. And as you can see here, the times that can be solved for 4 different analyses are quite different, and we had to take 2 different approaches in order to evaluate these data. And as you can see, our first approach in the first table was to take the solution time of the analysis with the least solution time among all these analyses, which is 21 milliseconds, and the first 21 milliseconds of the other analysis. And our second approach, as in the second table, was to collect the maximum force data that we could obtain the data for each analysis, and taking into account the maximum solving times for each analysis. And we had to evaluate these 2 different approaches at the same time. And as you can see in this graph, the behavior or the tendency of the data did not change with the increase in solution time. Thus, we decided that the data obtained after a 21 millisecond solution might not have a major impact on the course of our analysis. And in the human model, we observed that static stress distribution by deformation analysis, when the maximum force data obtained from 4 different cart analyses were applied to the human model, the biggest reason we can get such a view here is that the model weight actually, and which depends on the gravity, and consequently, since the most pressure will be on the feet, the deformation that may occur is expected to occur here. Of course, considering the real situations, we cannot think of deformation on a person because we are not in a position most of the time in a static position. And as you can see here, the distribution of force increases as you go to the feet, depending on the weight of the limbs. And this is enough conclusion to begin our interpretation. When it comes to compare about all the results we got before, we can say that the force required to turn the cart is greater than the force required to move it straight. And the European type of shopping cart requires more force than the US type cart, and no significant difference actually in force was observed between the 2 models in terms. And when we compare the results of the analysis with different solution time intervals and the results in the first 21 milliseconds of each cases, we observed that there was no change in the required maximum forces. And as you can see on the simulations, that the maximum forces are the same for different solution time intervals. And as a conclusion, according to the results and evaluations that we made, we have been determined that the European standard shopping carts with 4 free rolling wheels need more force in case of going straight compared to the American standard shopping carts with 2 free rolling wheels and need less force in case of rotation. And from the motion simulations of the cart models and the examination of all the data obtained, it was concluded that the European type shopping carts cause more uncontrolled behavior in use. And well, even though our actual presentation takes longer, we tried to shorten as much as we can, and we will be giving other details in the full paper. And thank you for your listening and patience. I may go in Turkish if you have any questions.
Thank you very much for your nice presentation. Okay, do you have any questions?
Hocam merhaba, ben belki kaçırmış olabilirim de bu yaptığınız çalışmanın normal arabalardan farkı nedir? Ben bunu merak ettim. Belki kaçırmış olabilirim, kusura bakmayın.
Tamam, şöyle söyleyeyim. Normal arabalardan kast bu market arabalarının üretim standartları arasında. Şimdi şöyle, Amerika ve Avrupa standartlarında market arabalar açısından üretim standartları farklılıkları var. Ve biz bunların çeşitli kıyaslamalarını yaptık. Bu standartların kıyaslamalarını yaptık. İnsan beden üzerinde ne çeşit etki edecek, bunların kıyaslamalarını yaptık. Kullanım kolaylığını incelemek açısından. Bilmiyorum, sorunu karşıladım ama.
Anladım, tamamdır. Bir karşılaştırma
Evet,
oldu yani.
evet.
Anladım. Teşekkür ederim.
Okay, do you have any more questions? We have 1 more minute.
I can talk about our suggestions if you have time.
Just 1 minute,
example,
less than 1 minute.
Okay, we weren't actually able to complete the analysis properly since due to technical conditions, and we have some suggestions actually, such like different ground conditions maybe can be defined, like rough, curved, and bumpy grounds, and experiments also can be run for longer periods or on more powerful computers.
By the way, time has come, so
yeah,
we can
I
proceed
saw
to the next presentation. Okay, thank you.
Thank you for your
So we are in the
patience.
6th and the latest presentation. It's finite element vibration analysis of a functionally graded plate by Alif Nimbi Diambu and Mehmet Çevik. Okay, you can start. Alif is
yeah,
here. Okay.
Yeah, first of all, thank you all for being here. Today, I'm going to talk about this work we've actually started. It's not done yet. So we are going to show you or to talk with you about the first step of this work. We're going to talk about the finite element analysis of vibration analysis of a plate. It's not launching. I don't know why.
Maybe you can turn off camera to increase bandwidth of share.
Yeah, probably. Let me.
Okay.
Yeah.
Okay.
Okay, it worked. So first of all, I'm going to go over the overview or the outline of this work. We're going to talk about basically the aim of the study and a bit of functionally graded materials, model analysis, vibration of a functionally graded plate, to end up with a bit of conclusions. To start with the aim of the study and the methodology used, vibration analysis of functionally graded material or functionally graded plates under different boundary conditions is investigated in the study. And for that end, we model, a model analysis performed by using different power, low power with n equal 1 and 1.5 with ANSYS APDL. So talking about the low power, you can see from the right side different formulas that are used in the literature with designing this kind of materials, mostly in finite element computer softwares. So when n is equal to 1, we have a line, and when n is equal to 1.5 or higher than that, we have a power function. So a 50 times 50 centimeter plate was considered in this study, and we applied a pressure of 40 kilopascal. Then the dynamic response of the system is studied for both boundary conditions. The boundary conditions that we are using here, I presented before, CCCC. So we have all 4 sides clamped, and we have 2 sides clamped and 2 sides free of the plate. So basically, functionally graded materials are special composite with material properties that vary continuously through their thickness, resulting in corresponding change in the properties of the material. As you can see right here, the right side, general idea of these materials are quite composite materials, but the main difference is, we have some major problems with the traditional composite materials, more especially with the boundary between layers, or when it's loaded, most of the time they might appear cracks or shear between layers. So implementing a functionally graded material will allow, or should allow, to have an evenly distributed material configuration. When I say even distributed, we have one side, for instance, with a ceramic, and the other side with a metal. Most of the time, steel is used together with ceramic. So this concept was, first of all, the first time used, or maybe introduced in 1984 by a group of researchers from Japan. So the aim was actually to go into space, and the engine, or maybe the aerospace engine, has to overcome at the same time the temperature and the pressure. So as we know, ceramics are good in overcoming temperature or supporting temperature, but they are brittle. Being brittle, there was actually a problem with using ceramic. So the idea came to take advantage from steel properties, at the same time ceramic properties, and then this kind of material has been introduced. So in this study, actually talking about vibration, we actually basically talk about the dynamic response of systems. When we load a system, or maybe we load a machine, the machine will respond dynamically. So model analysis is used. It provides, for instance, for a particular input, it might be a loading, I don't know, on a bridge, or maybe a loading on a machine. What are the limits of the system's response should be investigated, so that we know if the loading we are giving to the system and the natural frequency of the system will get to go well together. However, when the frequency of the loading is the same as the average vibrational frequency of the structure that can be a machine or any other kind of construction, the energy is transferred with minimum loss, and therefore they tend to add up together. Adding up, that will actually lead to a bad situation, which can cause most of us actually probably already heard about resonant vibrations. With resonant vibrations, the system is actually in danger to break down. And we had some example in the past. For instance, we recall the Tacoma Narrow Bridge disaster in 1940. The wind were blowing at a particular frequency, which happened to coincide with the resonant frequency of the structure, resulting in sudden collapse of the structure. So when engineers design structures, they always, for instance, in this case, we are studying here, we just took a part of a structure. That plate or any other structure has a natural vibration frequency. So where the engine or maybe the structure will be working will actually be important to investigate what is the vibration frequency of the system and the vibration frequency of the loading. Loading can be wind for the situation here or other kind of loading. I recall here at the same time in the past, one engineer in my home country, after doing a great project, the project was successful and done. It was a 2-story building. And then after the project owner asked him if it can be possible for him to use machine on it. So the structure was well constructed and everything seemed to be perfect. The engineer, without thinking about all these details, accepted, saying that it's okay. I'm sure about my construction and you can even use vibrating machines because I know that it can go longer than now, maybe 30 years it can go. So just believing or maybe considering the duration of the structure to go, they made a great mistake. So the structure was not designed to receive those vibrations, and it's happened that not more than 2 days it's collapsed. So it might be like a joke, but there are serious problem to consider in engineering designs. So basically here we have the natural frequencies, and when the natural frequency is equal, you see here omega A and omega 0. Omega 0 being the natural frequency and the input frequency, which is the frequency of the loading. When both are equal, so both frequencies are going to add up, and adding up, that will result to breakdown or adverse situations going to infinity. So for our case, it's just a plate that we analyze 50 times 50, 10 millimeter thick, designed with ANSYS APDL. 40 kilopascal was applied to one side of it, ceramic side, and results for both boundary conditions are presented below. So the first frequency we came up with, and most of the time when we design, we consider the first frequency, and with both frequencies, we find out that we can see from the left side and the right side for the same dimensions of plates, frequency when the material that has been designed with a linear pattern and the other with an exponential pattern, or not exponential, with the 1.5 of power, we find out that results are different. So here, what I want to show you or point out is everything goes firstly from the manufacturing process. So when manufacturing, one who actually consider a linear distribution of material throughout the structure, and the other one considering a powered function for distributing the material. Difference might be quite not that much, but it is not to be negligible. Since we have, for instance, 748 hertz for and 1 and 790 for endpoint 1.5. As I mentioned, this is just one step on this study. I hope that when the full paper will be done, we come up with more than this as a result, comparing, for instance, results in the literature and other graphs together with the amplitude and other. So I showed up the second, and this is the third vibration mode. So I don't have much to say about it. So this is the other boundary condition when we consider a clamping from both sides or two sides only and leaving free the other sides. And we see that the system frequency, first frequency is lower than the first vibration frequency. Yeah, this is basically the starting point of this study. So in short conclusion, I can't say directly that this is a conclusion. As I told you, it's a first step to this study, but what we have at this step observed, although the study is still ongoing, we can see the influence of actually boundary condition together with the power factor n. And with increasing n, we observed an increase in natural frequency response of the system. And with increasing n, we observe an increase in vibration amplitude. Further results are to be discussed in terms of the study, comparing the results in the literature. So said, I thank you. If you have any question for this presentation, I'm happy to have it from you.
Thank you very much for your nice presentation, Ali.
Thank you, sir.
Are there any questions? Okay, if no, we can end this session. So there will be a half an hour break, and the next sessions will be at 4 p.m.
Sercan Hocam.
Buyurun hocam.
Kapatmadan bir toplu fotoğraf alabilirse
tabii.
Arkadaşımız. Ben de şöyle yapayım. Aldık mı arkadaşlar fotoğrafı? Herhalde
Bir dakika hocam, alıyorum. Tamam. Teşekkürler.
Biz teşekkür ederiz bütün arkadaşlarımıza ve Sercan hocamıza.
YouTube yayınımı sonlandırıyorum, bilginiz olsun. İyi günler herkese.
Görüşmek üzere.
Değerli arkadaşlar, kapatmadan önce müsait olanlar kameralarını açarsa bir beraber fotoğraf alalım. Evet.
Alayım.
Teşekkür ederim arkadaşlar. Sağ olun. Görüşmek üzere.
Görüşmek üzere hocam. Teşekkür ederim.